Good morning.
Good morning, sir.
Good morning, sir.
Right, sir.
So last class, are you getting my voice clearly?
Yes. Yes, sir.
Okay. Hmm. Last class we started discussing this problem, and today we will start from here. Let me take this to a new lecture note. So, so it was lecture number 11. And today we'll start lecture number 12. Not doing good. Okay. Mm, So this is a problem which is for link mechanism where for this instant the one of the link OA is this is not visible, right?
No,
Whiteboard
sir.
not.
Yes, sir.
Now is it visible?
Visible now. Yes, sir.
Yes, sir.
So this is a one of the instantaneous configuration of the mechanism where this link OA, which is for this case a follower, is vertical and this link BC is horizontal. All other dimensions are given. Okay, we need to find out we need to find out what is the angular velocity and angular velocity of OA and AB, and then we will find out what is the angular accelerations of these two links OA and AB. Okay. Let's start. Whatever we have derived in our last class, we'll be using those derivations. Before we do that, let us see what are the given data. So we are calling this omega OA is a vector, but on the rotation of this link, we don't know in which direction it is rotating. Suppose it is rotating in this direction, then we can say that omega equals to whatever magnitude of omega OA, and its direction is in the k direction as we have defined I and j. So k is perpendicular to that. When a link is rotating in this direction, we will say its rotational direction velocity is k in the k direction. So any vector can be represented by its magnitude and its direction. Okay, then omega, this we are calling omega OA vector. Okay, similarly, you can define this vector omega CB. Okay. This is omega CB. Already we have written here So this omega CB, which is given here, that is 2K. This is radian per second. This is given. This is also the unit is radian per second. And then what we need to find out is omega AB. This we need to find out. This vector, let us call it omega AB, the magnitude, and it is rotating in k direction. Let us assume like this. If it is not so, suppose the what can happen? Either this link can rotate in this direction, or it can rotate in the opposite direction. If it is rotating in the opposite direction, there will be a minus sign, negative sign. So only this magnitude can carry the direction, because depending on its depending on whether it is positive or negative, right? So when it is positive, that means this is rotating in the anti-clockwise direction, and when it is negative, this means it is rotating in clockwise direction. Okay. So now we define the position vectors R A, which is nothing but R O A, R O to A. Okay. So we are not writing R O A, we are just writing R A. That R A, the two definitions have some so when I write R O A, so that means it is O to A, the position vector. On the other hand, if we write V O A, that means velocity of A. Sorry, if you remember, we have used this in our last class. We have used this quantity VBA, B velocity of point B with respect to A. Let me write this without making any confusion. VBA means velocity of B with respect to A. So you should not be confused with these notations. You can change the notations. You can write it R A O. Okay, then there is no confusion. Position of A with respect to O. Okay, don't spend much on these definitions. Just understand what is happening here. So this, what is the dimension RA? Can somebody tell me what is this vector RA?
100G.
100,
100G.
100J,
100J direction.
right? And what is this RB vector? RB is nothing but R CB. C is a fixed point. RCB. What is this?
Minus
75 by
Minus 75I. What is RAB? RA
minus 75 I
minus
minus
50 I cap plus 50 J cap.
175 I cap plus 50 J. All the dimensions are given in millimeter. Okay, so I am not writing. You can write here, there in millimeter, and this velocity is in radian per second. Okay. Now, once we have this data, all of you understood why this is RAB equals to this?
No, sir.
So you see, this is point A and this is point B. So if you define a vector from this point to this point and call this vector R A B, then from this point A, okay, from this point A, if you go along x-axis, how much distance you have to go? Bono,
250.
250.
175.
सर 250 ना
250 है नीचे में लिखा हुआ
250 है सर
Okay, I did a mistake while giving this dimensions. This is 250. That's why the problem is. Okay, this whole length is 250 from this point to this point. This whole length is 250. This is 75. So you subtract 250 minus 75 gives you how much? 175. This is 175. So this is 175 I,
yes sir
and then you have 50 in this direction.
so the minus j
Okay, this is in minus j direction. And I have just written the other way. Actually, ROA means R. यहाँ पे हम लोग opposite direction में ये vector को लिए हैं, ठीक है? Let us call it. If I call it R BA, then the vector is this one, right?
yes
ऐसे
sir.
हो जाएगा.
yes
yes sir.
Then this is fine, right? Then this
Yes,
is R BA. Okay,
yes sir.
is it fine now? First, we have to go in this direction. How much? This is 50J. And then we have to go in this direction. How much? This is minus 175I. ठीक है ना? ठीक है?
Yes sir.
It's simple, but
Yes sir.
there was some confusion related to this uh, definitions of these vectors. ठीक है? Now, what we will do, we have to find out angular velocities of OA, OA and AB. Actually, if we can find out velocity of point A, then all these quantities can be obtained. See, if we can find out velocity of point A, this link is just rotating about this link. And you know, from your graphical methods, the direction is known to you. So, which is perpendicular to this direction, and it is simply, see, if suppose a link is rotating about some point, then you know that there is no point of calculating the relative velocity part. It has only one velocity component, that is omega cross r. Agreed?
Yes sir.
So let us first find out this what we can write down about this velocity of point A. So velocity of point A can be written as velocity of point B plus velocity of point A with respect to B. Agreed? Hello?
Yes sir.
Yeah.
yes sir.
And there is another way of writing the velocity of point A. What is that? With respect to O. Yeah?
Yes sir.
Velocity of A can also be written as velocity of point O and velocity of point A with respect to O. This is nothing but, you see, the point O is a fixed point, so its velocity is 0. Its velocity is 0. And V, if it is rotating with respect to a fixed point, and that point's velocity obviously equals to 0. So we generally write that this is velocity of point A. Okay. So from these two equation, we will write, I will correlate it with your graphical method. Okay. Just this two equations you have, and from these two equations, so you have two equations. From these two equations, how you solve two unknowns. Okay, that's what you do in your graphical method, and you will see that what is the correlation between this analytical method and graphical method. Let us complete this first. So this is equals to VB plus velocity of point A with respect to B. Now, if we elaborate, what is this quantity? How can we write down from our previous day's discussion? What is this? VA with respect to O. What is BA with respect to O? Any velocity has two components. Any this suppose uh, velocity has two components. One is, suppose that is rotating. So V, let's say AB, any 2 points, VAB has two components. One is omega cross R B to A. Okay? Another is the
dr by
differentiation,
dt.
dr by dt, RBA by, and it is in the RBA direction, right? But in this case, for this case, how many components are there for this case?
Only
Because
omega.
this, yeah, because this length is not changing. So that is why this derivative part is not there. You have only omega cross R, and we will write ROA. Just do not be confused. Here we are writing RVAO, and here we have written ROA. The definition I have given. Okay. The two things that we have defined in a confusing manner, but you can choose your definition. Okay. So let us not write ROA. Let us just write RA. Here we have written RA. And this omega is we have written omega OA. So let us write down this omega OA cross RA. And this is equals to, I'm spending much time here so that all of you understand this clearly. Now let us write down what is the velocity of point B, this point. How can I write velocity of point B? As I said, any velocity, any links in this point's velocity has two components, this component and this component. Obviously, there is another component, but this is fixed. Let us write here what is VB. As we have written for VA, VB can also be written in this form. Okay, so VB can be written as velocity of point C plus velocity of point B with respect to C. Okay, and you know the C point is a fixed point. This part is 0, and velocity of point B with respect to C will have only this component omega CB, and that crossed with RCB. ठीक है?
Yes, sir.
So this is omega CB cross RCB. plus. Now, what about this velocity of A with respect to B? As we have already discussed, it has any value, this relative velocity of A with respect to B. It has two components, but you see this component is equals to 0. Is it not? So it has, you have the omega, I have written here omega AB cross R BC, right? Sorry, ये बोल गलत लिख दिया, R BA. Fine. If you have understood this, then we can go further. Hello, is it fine?
Yes.
Yes, sir.
Yes.
Yes,
Yes.
sir.
If this equation is fine, now you understand what is this is the key equation which came from this equation. We have this equation. This is the key equation. Any equation for planar motion, there is a vector equation. Any vector equation actually equivalent to two algebraic equation. Because you see, if it is a planar, then you will have I component in this vector equation. You have I component and J component. And then since these two components are perpendicular, the directions are perpendicular to each other. So you can separate the coefficients of I component and coefficients of J component. Then you have two algebraic equations. You have done this earlier for vectors. Now let us put the values here in this equation. If you put the value omega OA, which we have written here, this is omega, not vector, just we are writing the magnitude, and then K multiplied with RA. What is RA? We have written here 100J. Now tell me what is omega CV,
2K.
and then बोलते रहो
Minus 75 I.
Minus 75 by
minus 75i, then
Omega AV K cap.
omega AB K cap, then
cross in bracket minus 175i plus 50j.
can you do the multiplications and tell me finally what you are getting from here? Kj is I. So this is 100 omega OA into I. What about this? Ki is, sorry, Kj is minus I, right? K
Minus I.
multiplied
Yes.
minus I. And where, what is it? Ki is K multiplied with I.
Minus
This
I.
J.
K multiplied, that is J, and 2 into 75, 150 J, plus what about this Ki is again?
J.
So that
Minus.
is minus 175 omega AB J, right? And what is the last term? K into J,
Minus 50.
Minus I.
Yes, I.
Oh, right.
minus 50 omega AB I. ठीक है? As I said that this is a vector equation in a planar motion, then this vector equation is equivalent to two algebraic equation. How? We just separate coefficients of I and J. When you separate coefficients of I, unit vector I, so you have omega OA is equals to minus 50 omega AB. Is it not?
Yes, sir.
Yes.
So what we are getting from here, omega AB, something we want to find out, is equals to
minus 6 by
twice,
7.
Twice of omega A.
twice omega OA, right? Now let us find out this equation, J components. So you have 150 plus 175 omega AB, and this is equals to 0, right? So from here, can you tell me what is omega AB? Minus
Min-
6.
Minus 6 by 7.
This is radian per second. Now you see one thing. This is minus 6 by 7 radian per second. What we have assumed? This is omega AB is positive, we have assumed. We have started with that. This coupler is rotating in the anti-clockwise direction. Whereas when we find out the value of omega AB, it is negative. Okay, that means in actual case the coupler is rotating with 6 by 7 radian per second in the clockwise direction. Is it clear to you?
Yes, sir.
Yes, sir.
So I'm writing it from the note. I hope this is correct. Right? So once I have this, we can find out from here, we can find out what is omega OA, right? So can you tell me what is omega OA? ठीक है? Is it so?
Yes.
Yes, sir.
So the value can be written as this.
Negative sign, sir.
Negative. This is also negative. Good. Now let us solve the problem. Now, we have solved the problem. The angular velocity of AB and angular velocity of OA. Now, if I give the same task using your graphical method, what you will do first?
Locate fixed points.
Hmm? Locate fixed points. So suppose I start with I start from this point. This is a fixed point. Okay. So your fixed points are here O and C. Then
Then So draw we'll draw a vector perpendicular with, to OA. yes.
you will draw, suppose you want to draw this the velocity vector VB. What is it? यहाँ से देख के बताओ. Because this is only given, right? (2k) and this distance is 75. So what is
75.
BB? What is BB?
150.
So you
150 minus J.
minus J.
so you know it is 150. And from your graphical methods, if you don't know what is J, what is K, you know that the velocity is perpendicular in this direction. So we have to draw the vector in this direction, right? VB.
Yes, sir.
C point से हम लोग VB draw करेंगे ना. VB, how will you draw and what is the value? Value will be the 75 multiplied with this omega CB, which is 150, right? ग्राफिकल मेथड में ऐसे ही करते हैं ना.
Yes, sir.
Yes,
So
sir.
Yes, sir.
you know you will choose some scale and you draw this vector, which you call this is 150 millimeter per second. है ना? I'm not writing the units. 150 millimeter per second. And then what is known? What is known to you? What about VA, velocity of point A? What is known to you? You don't know what is the magnitude of that vector, but you know what is the direction, right? It should be
Yes,
along
sir.
this line, perpendicular to this link OA, right?
Yes.
So from the fixed point, suppose this is your fixed point we have started with. From this point, you know that this velocity component VA must lie on a straight line like this. Okay? VA must lie on this straight line. Obviously, VB we have got, it is given. Okay. Now, what else is known to us?
Direction of BBA.
Direction of BB from this. No, from this coupler, something is known to us. What is that? A point's velocity with respect to this coupler. So at this instant, B point is here. This coupler is rotating with respect to this point B. That means you know the velocity of this point A with respect to B is perpendicular to this link. Yes or no? Hello?
Yes, sir.
Point A,
Yes.
its velocity is perpendicular to this link. When you find out velocity of point A with respect to B, that means with respect to point B, a point is rotating. We don't know what is the rotational velocity or angular velocity of that rotation, but we know the velocity of point A is in the perpendicular direction of this coupler, right? So you draw that here. You draw a line which is perpendicular to the coupler, and then that line intersects at this point here, and that gives you the solution. Then you say that okay, that means this is velocity of point A, and sorry, and this is the line which is representing velocity of point A with respect to point B. Got it? Let us go back.
Yes, sir.
This is your graphical method. Let us go back to this equation. What we did here, you see, this is a vector VA. This is the vector VA. You have this vector VB. This is VB. And this vector VAB. VAB. The equation which we have written here, VA is equals to VB plus VAB. You see here, VA is equals to this plus this. That is the equation. We have actually drawn that equation here. Now you see how your graphical method come into existence. From this, you can find out this. So what happened earlier days? Earlier days, these computers were not there. So that is why this method, people have used this graphical method to find out for a particular configuration what is the velocity and acceleration. Sometimes you avoid these calculations, only directions, these equation solving things, you avoid equation solving, only this graphical method. Actually, this is also the solving two algebraic equations. How we have solved two algebraic equations? Now this is interesting. You see here, we know this is one direction. We know this is another direction. When they are intersecting, that gives you the solution. So here you see that one of what is this direction? This is I direction. That is nothing but gives you this equation. And you have you cannot directly compare them I and J, because this is just perpendicular to the RB. But you see, this is similar. Because there is another way. Am I trying to tell you that this algebraic equation is a combination of two. Sorry, this vector equation is a combination of two algebraic equation. And for this case, since we have defined the unit vectors I and j in this direction and this direction, that is why we have these two equations. One can also define two unit vectors. One is in this direction, say let's say I. You can define another unit vector in this direction, which is perpendicular to the coupler. Okay, you can define that. Suppose P is another unit vector, or uh, okay, P is another unit vector which is in this direction, and you can write down the whole vectors. Here we have written in terms of I, J, and K, and their relations are like I, J perpendicular to K. You can define vectors like I, P, and some other vector in the perpendicular direction. Then their cross product will be something different, will be defined. In that way, if you define in that way, you will get this same thing. Okay. To realize this, you need to write it and practice it. And what is the use of that? Use is when you practice it and learn it properly, then you obtain some expertise. Then your base, somebody asks you some question related to basics. Your ideas are not shaky. You can answer them. Okay. So here you see from this diagram, you will only this is known to you, and you will measure all other things. VA, as we have written, VB plus VAB. Okay, where this VA we have obtained, this is 100 omega OAI, and VAB was equals to omega, क्या था, VAB equals to omega AB cross RBA. ठीक है ना? Again, in another way, I am showing you. So VB is known to us. We have drawn this. Now VA is this. How to find out VA? So if you know VB, that plus VAB. Already VB is known to us. Now V plus VAB. What is VAB? VAB is omega AB multiplied with RBA. Now omega AB always in direction of K. K multiplied with RBA. RBA, that direction is, this direction is RBA. Omega direction is K. Now if you cross multiply these two, which direction you will get?
Perpendicular.
Perpendicular to this, and again, if I have taken this rotational direction is this, then perpendicular, and in which direction? This direction or this direction?
Downward.
Downward.
So we'll have downward direction. But actually, here the interesting thing is, so actually you have got this perpendicular direction. That direction is given by this line, right? देखो, VB plus VAB. So VB to known to us. This is this. From this point, we'll draw a vector by this. But we don't know what is the magnitude. We know the direction. So we have drawn this one. Okay. And from VA also, we don't know exactly what is the magnitude, but we know the direction is I. So you can draw this. Then they are intersecting, and that is the intersection point. What I am again and again trying to tell you that this graphical method is nothing but just plotting of this vector equation. Okay. Let's go to its second part of the same problem. The second part is we have to determine the angular acceleration of links AB and OA. Okay, determine angular acceleration of AB and OA. So, up till now, we have done the velocity analysis. Now we'll do the acceleration analysis. Okay, we'll do the same thing. Here also we will write what is the acceleration of point A. Let me draw the same figure here so that it is easier to refer. This is point A, B, C, O. Right. Now tell me what should I write? What is acceleration of point A? Can be written as
Alpha into R A.
Let us first write down in terms of this vector equation, then we will write it. Type
AO plus AOA.
Acceleration of O plus acceleration of A with respect to O.
so acceleration of A with respect to O. There is another way you can write down this. You have in
Acceleration of
this acceleration of
B plus acceleration of A with respect to B.
B.
ठीक है. Now you see one thing. What is this AO?
0.
This is 0, right?
0.
So from these two equation, what we have? Acceleration of A with respect to O is acceleration of B plus acceleration of A with respect to B, right? Okay.
Yes, sir.
So now we go back to our derivation. Any point's acceleration, any point like this, acceleration of, let's say I am writing this way, acceleration of A with respect to B. How many components are there in this acceleration?
2.
No, not for this particular case. Just consider there is a link in space.
4.
There are 4 components, right?
4 components.
Hannah, 5 component is the fixed points acceleration, and then any point if you know this point's acceleration, then with respect to that other accelerations. So actually, how many components are there? 4 components, right? So what are these 4 components? Let us write down here. What are these 4 components? First one is alpha AV cross R. Let us write it BA plus what is next? ओमेगा भूल गए हो?
क्रॉस R.
ठीक है, थोड़ा याद दिलाते हैं, है ना? This is the expression. Can you see it? This is the expression. So the first expression is alpha cross R. Second expression is omega cross R. Third expression twice omega cross B relative. Fourth expression A relative. ठीक है? These are the four components of acceleration. So what should I write here next? Omega AB cross R BA. What is next? Third component, which is called Coriolis component, 2 omega AB cross
relative.
V relative. What is next?
A relative.
A relative. But for this case, if you consider this one, just let us write down what is this acceleration of A with respect to O. How many components we will have? Let us write down all four components for this. Then we will see which one is relevant to us or which one is not. Okay, let us write down because this is a problem we are solving for example. So we must understand each and everything. So alpha, let us write it alpha AO cross R OA. This is the first term. Second term, so omega AO cross omega AO. Many of you may be thinking why should we complicate this simpler problem into this so many equations, so many terms? Because if you understand a simple problem, application of this methodology into a simple problem, then only you can solve a complicated problem. All your practical life problems are not that simple which are given in your book. Okay, you have to solve them, and to solve it, the method, the process is first you split them into simple problems. Okay, and if you know what is the basis, what is the background, then only you can split it into simple. Okay, otherwise your whatever you will write, they'll be flawful. Okay, so that is why we are writing all the terms. Then we will see which terms are relevant to it, which terms are not. So what is the third term? Can somebody tell me what should I write now? Omega
AB.
AO.
omega AO. Now we are writing V relative. So can I write V relative for the link OA just to differentiate from other? Uh, okay. And what is the last term? A relative. So A relative for OA link. Now in the right hand side we have this one, acceleration of B. As I said, this acceleration of B can also be written as acceleration of B can also be written as acceleration of B with respect to O, right? है ना? जैसे acceleration of A लिखा है ऐसे ही acceleration of B भी लिख सकते हैं because A and B are some similarity. What is the similarity? This link OA is rotating with respect to this fixed point. This link CB is rotating with respect to this fixed point C. So they have some similarity and we can write down them this way. So now if we want to write down what is the acceleration of point B, let us write down all the terms. बोलो पहला term क्या लिखेंगे? For acceleration of point
Acceleration of alpha BO
alpha BO BC होगा, ठीक है? और फिर point C है and then
RCB
RCB
CB.
plus
Omega BC.
omega BC
हाँ बोलते रहो.
omega BC cross RCB
CB.
plus 2 omega BC cross V relative CB
हम्म
plus A relative of CB.
Okay. Now tell me what is this component. This one. क्या term रहेगा?
Alpha
बोलो. Alpha
AB
RBA
cross RBA plus
plus omega
AB
AB
cross omega AB cross RBA
RBA
plus 2 omega BA, sorry, AB
omega BA
cross
और omega
V
AB are
relative.
the same, right? Omega BA
Yes, sir, yes,
और
sir.
बोलो और omega AB are the same. Angular velocity same. Angular velocity actually is very interesting. I'm not going into those things. Omega AB into
Cross V relative of BA
BA.
plus A relative of BA.
Let us now see what are the components which are not relevant to this case. Left hand side देखो. Is this relevant to this case?
Yes, sir.
Okay,
Yes,
because
sir.
there can be some angular acceleration or it is non-zero. So this is valid. Whether this is valid or not.
Yes,
yes
sir.
sir
This is valid.
Yes, sir.
Valid.
This is valid or not.
No, sir.
not
Why?
No, sir.
Why?
V relative
There
Relative not
is no V relative is not there.
Okay. Now, what about this component?
0
0. A
This
relative is
is
not there.
0. Now, for this case,
Same as previous one for the first
so
equation.
only we have these components are 0. From whole discussion here for this problem, these components are 0 because there is no relative velocity and relative acceleration. These components are 0. So everywhere you have two components. And you know that these two components are, one is tangential and one is along the length of the link. Okay. Now you see for velocity we have written this equation, and as I said that this diagram is the plot of this equation. Similarly, for your acceleration diagram, you plot only this equation. How, we will see later. First let us solve this problem. Okay. So to solve this problem, let us first find out this component one by one. Okay. So let us write down what is omega OA. Sorry, alpha AO. Is it known to us? If it is not known, then let us write down its magnitude and say its direction is K. Okay, and then what is ROA, which was RA, if you remember?
100J.
100 J.
100J. Just write down this. This is 100J. Plus, what is omega AO? This one, right? Omega AO we have already obtained. Minus 3 by 7 K, right? Let us write down that 3 by 7 K. यहाँ पे भी लिखो minus 3 by 7 K, and this multiplied with RA, what is 100 J, and this is equals to, what is alpha CV BC? Not known to us. Let us say
Not
that
known.
and what is R CB. Is it known to us or not? Alpha BC. This is equals to this is equals to 2k radian per second. Another thing is this is constant. And now you can see this is constant. If this is constant, that means what is alpha CB? This is equals to 0. Okay.
0.
So from that, here another term, this term does not exist because this is equals to 0. Okay. Okay.
Yes, sir.
Let us write down
Yes, sir.
then what is omega BC?
2k.
Omega BC is 2k. 2k multiplied with 2k multiplied with cross multiplied with RB. What was RB?
Minus 75i.
Minus 75 I. Okay. ये
Sir,
हो
in the
गया?
left hand side, second term is cross product.
Yes. These are the things we must not do any mistake. So now tell me what is alpha AB? Is it 0 or known to us or not known to us?
Not known to us.
So let us
Not
take.
known.
Okay, let us take this. What is RBA?
Minus 125i plus 50j.
What about the next terms? Omega AB. What is omega AB?
Minus 6 by
Minus 6 by
7.
7.
Minus 6 by 7 K. So this is minus 6 by 7 K multiplied with again minus 6 by 7 K cross multiplied with R, which is 175 I plus 50 J. Okay, we have completed. Now can somebody tell me one by one these quantities from the first what we will get?
Minus 100.
Minus of 100 alpha AO. I direction.
Then यहाँ पे क्या मिलेगा?
0.
के जे मल्टीप्लाई करोगे तो क्या आएगा?
Minus I.
जे माइनस आई आएगा एंड के इंटू आई मल्टीप्लाई करोगे तो के इंटू आई इज
J.
जे.
Minus.
ठीक है. So we have one minus sign. This minus you have plus and then one minus sign, right?
Yes, sir.
Yes, sir.
This is 9 by 49 into 100. है ना? And what should I write here?
J.
J. Now tell me what is the next quantity? 300. What should
Minus
be the sign?
300 I.
K into I is J, that is positive, and K J is minus I.
Minus I.
So that minus I and this minus gives you
Cancel.
300 I. ठीक है? ठीक है?
Yes, sir.
Yes.
Next term, this term, one by one बोलो. इसका multiplication क्या देगा? Ki is
Plus 175 अल्फा ए बी जे
प्लस क्यों होगा? के आई इज जे ना,
माइनस
माइनस जे सर
minus 175 alpha AB J. And then what is the next term?
minus 50
सर
alpha
के
AB
आई सर माइनस जे
to I.
No, KI is plus J. K उसके बाद I है ना, I J
ओके सर
K. KI is
यस सर यस
ठीक है। ये बताओ ये क्या होगा? KJ
Minus
is
50.
minus I.
Minus 50.
So
माइनस
this is
50 है
minus 50 alpha AB
आई
I.
I.
उसके बाद ये टर्म्स पहले बोलो। First you have to multiply this one and this one. Do this multiplication and tell me what are the values you are getting. Do this multiplication and tell me what you are getting. Finally, what I got by separating this coefficients of I, that is equals to 100 alpha AO this is equals to 300 plus 36 by 49 into 175 minus 50 alpha AB. Tell me, have you got this? Calculation करके मुझे बताओ.
Yes, sir.
Have you got this?
36 by 49 into 175 आई
है ना, ठीक है ना? तो I have just taken the coefficients of I. So the first component you are saying that it is 36 by 49 into 175 I, right? And the second
यस
component
सर 36 by 49 into 50 जे
36 minus है ना,
यस सर माइनस
Yes, sir.
into 50 J. So when you separate them, the coefficients, here you have 36 by 49 into 50 minus 175 alpha ठीक है. Can you solve this too and get the values of alpha AB and alpha OA? बताओ क्या मिल रहा है ये दो इक्वेशन सॉल्व करके. From here you directly get alpha AB. What is the value? Minus 0.105 radian per second square. Have you got this?
Yes, sir.
And what is the next one? Alpha OA.
Sir, alpha AB equal to 0.105 minus 0.10.
ठीक है. Alpha OA.
minus 4.33.
Minus 4.33 radian per second square. Okay, if you allow me 5-10 more minutes, I can show you that how you get the same thing using acceleration diagram. Extend करें और 5-6 मिनट. Okay, what I'm giving you this task. Just draw the diagram using this equation. Okay. Tomorrow I will discuss, but you try on your own, and whoever can solve tomorrow in the class, please show me. Okay. All other lecture notes I've already posted in the team, so I hope you have these lecture notes, right? All of you have the lecture
Sir.
notes? Bolo?
Sir, one question just.
Hmm.
Sir, in normal cases of link, like combination of link, sir, वो acceleration का जो दो component है, Coriolis force का और A relative, sir, in general वो zero रहेगा ना, कि link के केस में तो change नहीं करता है.
If the link length is not changing, tomorrow we will discuss a situation where that is not zero. Okay. In our next class, tomorrow we will discuss a situation where that is not zero. Okay. So sir. What? We will discuss that case, and after discussing that, we are at the end of this discussion. One more example I'll take in our next class tomorrow. Then I'll finish this kinematic analysis part. Okay. So what you should try to find out, not find out, you just draw these vectors. Okay, how to draw this vector? This is completely known to you, right? The value and direction is known to you. So you can draw that vector. This is that vector. And then you see some other vector which is known to you. See, this vector is known to you, 300i. So you can draw that vector 300i. Okay. Any other vector which is known to you here in this case. See, this is known to you. Right. So you can draw that also. You can draw that, or you can use these directions. You can use. You see, this gives you some direction. That means you should go from this vector, then this negative thing. Okay, this is positive. This is completely known to you. Just you can draw that. Now you have another component which is known to you. So you can draw that. I don't know how much it should be. See, so in the right hand side, you have 1, 2, 3 components known to you. So you can draw 3 components. And then in the left hand side, you have 1 component not known, but you know the direction. Direction is in the I direction. So you can draw that. Similarly, from right hand side, you have this 2. Okay. From this 2, you can draw how much you should go in the J direction, how much you in the K direction, in the I direction, not actually known, but combination of these two. This is a vector. You see this itself, both thing when you take them together, that is a vector, and that vector's direction is known to you. Is it not?
Yes,
So
sir.
with all those things, when you add all those things, you will have a figure, and that figure somewhere you will have a intersection like this. That intersection will give you the desired value. Okay, I have drawn it not properly, just I am leaving it for you. You try it. Tomorrow we'll begin with this example. Okay, that's all for today. All the lecture notes you have got from your team or not? Any one of you have tried? Just now you can try and tell me. All the lecture notes are available in the team. I have uploaded. Just try and
Dead center, sir.
eh? Bolo?
Lecture notes are available up to dead center.
Yes, that was the last lecture. You mean to say this lecture is not available? 11?
Yes, sir. Only
I think 11 is available. Let me see. You see 11, 12 available. Okay, this is lecture number 13 because we have already lecture number 12 and all those documents are available. Okay.
yes,
All
sir.
right. Today I will send you this, upload this today's lecture also. All right. Thank you for attending this
Thank you, sir.
class.
Thank you, sir.
Thank you, sir.
Thank you.